Well, thank you all for joining us. Good morning, good afternoon. Hello, if you're watching this on demand at a later date. Welcome to today's webinar. Today we're joined by Ryan Schneider, and thank you guys. This is the part 3 in our KubeAcademy Kubernetes core concepts. And this week, I think we'll be covering cluster concepts. Is that correct, Ryan?
That is correct.
Yes. So if you haven't already, let us know where you're dialing in from. We do want to keep this as engaging as possible and as interactive. So if you have any questions, please type them in through the Q&A chat or through this chat, and we'll get through them throughout today's presentation. Without further ado, I'll hand this off to you, Brian.
Thanks, AJ. Hey, everyone. Thanks for joining. All the same greetings that AJ said as well. And I am in Central Florida for today. So a nice hot and humid summer day here. And so I've been lucky throughout my career to travel most of the world. So I have been not to Sanket, but I have been to Bangalore, Colorado Springs, yes, Oklahoma, Honolulu, yes, Tennessee, most of the places, believe it or not. So yeah, with that, this is the office hours. So if you're just joining for the first time, or if you're coming from following, we're going through the KubeAcademy, and we are going to specifically to learning paths. And there is the Kubernetes core concepts one. And we've already talked about part 1 and part 2. And today is about part 3, which is cluster concepts. And so as a reminder, what was done in the part 1, we look at the outline for that. It was all about getting a web application and a database backend containerized and using Docker. Then after that, we actually put it in Kubernetes and learned about the basics of Kubernetes and then how to troubleshoot it. Then we went into the last time we had one of these, I showed about deployment management using canary deployments, pausing and starting deployments, and all of that built-in behavior that the deployment object gives us in Kubernetes. And now this time we're going to go in and talk a little bit more about cluster concepts, specifically the networking in Kubernetes, and then resource organization about how namespaces and other things work. So I'm going to go ahead and launch this lab and get it going for us. And I'm going to follow the same similar format to before. I'm going to basically do a walkthrough of the lab. That'll help get us warmed up. We can look at stuff. You're welcome to follow along with me at KubeAcademy and do the same thing yourself, right? And I'll go through this one, then we'll field some Q&A. And then I'll go through the next lab in this part, which will be the resource organization lab, and do the same thing there. So that's the rough what we're going to outline of what we're going to do. If there's any questions anybody has before I get started, and while I prepare the lab, just pop them in the chat, raise your hand, or in the Q&A. So as most of these, we have a bootstrap command that will get this lab up to the state it would have been if we manually went through labs 1 through 5. So it's building those Docker images, it's pushing them to the registry, it's going to deploy them into Kubernetes, it's going to add some of the probes and other things to them. And then here in a little bit, once this is done, we'll check the state of it. We should do a kubectl get pods, and we should see our stuff running. Okay. Now, what this lab is about in networking, I'm going to talk through this part while the lab is bootstrapping. If you recall, in Kubernetes, a service can have multiple types. By default, if we don't give it a type, it's cluster IP. I really wish that was a different name, but that's okay. What it refers to is that if I want to talk to that service from another entity, like an application or another running pod, I do that by communicating to it on an IP address that is only accessible with inside the cluster. So I can't access it from outside the cluster. And so what we did earlier in the labs is we changed that. And instead of being cluster IP, we exposed it as a node port, which basically means that it opens up a port on every node in the cluster, and that port is uniquely assigned to this service. And so in those, when it's uniquely assigned to that service, that means as long as I hit that port, send traffic to any node in the cluster on that port, that traffic will get routed to the service in question. Now that it works, it's great, and it works especially well for layer 4 traffic, non-HTTP layer 7 URL traffic. However, a lot of stuff we do today is web traffic or REST APIs over HTTP. And therefore, the common way to expose things is using Ingress, which does layer 7. When we use Ingress, we go through Ingress controllers, and therefore we're bypassing the node port, and we don't have to open up all these ports, node ports on every node. So for that reason, we're going to actually change our service to be cluster IP as instead of node port. You might ask why this is terminating. It'll be running in a second. Kubernetes always self-heals, right? It's getting to that desired state, and it was failing some checks as stuff comes up at different times, but it eventually gets there. So we got this running. We're all healthy. Now, if I inspect the service for the Go web app, right, it is type node port here. All right, and we can also describe it, and it should show us that. Notice it's type node port, and the current node port that's assigned to it is 31496. Now, you might wonder, well, Ryan, why is it asking me to delete this thing? And it won't. That's because it doesn't allow us to change that. So if I actually went and tried to change it to the desired value of cluster IP, okay, and we go and look at it, what happens is it'll do checks and the traffic won't route. Now, what we're going to do is we're going to start fresh with it instead. And we are going to delete it from there and now apply it. And the reality is, you might say to yourself, well, why would Kubernetes do this? Or why would it behave this way? I don't want to have to delete my service. Service objects in Kubernetes tend to be long-lived, and they're not something you change all the time, right? You can think of it about like when you're launching a new app, how many times do you, once the load balancer, the DNS name for your application is there and established, how many times do you really modify it after that? You really don't. So the decision of this is something that you're not really changing throughout the life of your application. It's more of an initial setup thing. All right. So let's make sure, oops, sorry for the scrolling there. Let's make sure that the application, the service is there. Great. And if we describe it, we're at cluster IP and the node port is unset. Okay, so I can't access the application externally to the cluster, but I can internally. But now we're going to install Ingress. So let's, in order to set our application up to use Ingress, we have to write a rule for it. So we're going to take this code here, and we're going to make it's asking us to make a file called go web app-ingress. Put this in there. Okay. Now, basically, each individual Ingress controller changes. It takes this format and then it changes it to whatever the config file format that the Ingress is using. So if the Ingress is Nginx, it's going to change it to an Nginx virtual host configuration file that matches the rules defined here. If it's HA proxy, it's going to change it to an HA proxy. And if it's on Contour, it's going to change it into API calls to Envoy, the backing network layer behind Contour. And so once again, Kubernetes has basically given us this canonical standard API definition. And then each of the implementations map to whatever their actual configuration is behind the scenes. Now, you might wonder what this session namespace and ingress domain is. That's because every time you launch one of our labs in this environment, we have unique IDs generated. Things are running in different stuff because it's done on the fly. And so what we do is we're going to environment substitute that in. If you're not familiar with environment substitute, it's a clever command that allows us to basically take a file, and then for every $, curly brace variable defined in there, it will replace it with what is set in the current shell environment. So as you can see, when I did this and printed it to the screen, the variables have been substituted with what the runtime is for this particular lab session that I'm on. Yours will be similar, but with different IDs. So we can then pipe the output of that to kubectl apply with a dash to accept input from standard input as opposed to from a file. And we will put that into Kubernetes. Let's make sure it works. There it is. Okay, make that a little bigger. Whoa. Sorry about the scrolling. Okay. Now we can test. And if we take this URL here, the Ingress URL, and I put that into a new browser window, yay, we have our Go web app that we've been using throughout the Kubernetes Core Concepts learning path is up and running and routed through that Ingress. So that's a little bit about how Ingress works, a little bit reminder of the network and the different service types. And generally speaking, out of the box, most applications, especially web ones, APIs, etc., are going to define an ingress like this and have the inbound network traffic come this way. One thing I'd like to point out that makes it really nice is that, where the rules defined in this ingress object, right? So if I go back to here, right, where would these rules have lived in a traditional either VM environment running on vSphere or a traditional I have a server with I have a bunch of web servers and I have a load balancer. And if you were to all write answers, it would probably all be a little bit different. Some of you might store it on the actual load balancer itself, the rules there. Some of you might have it within the, if you're using NSXT, might be in that layer. Some of you might have it in your AWS or Azure configuration using an ALB or ELB or a load balancer. And it's not really within the code base of the application that's using it. What's nice about here is this YAML object gets checked into the source control of your code base that it's sending the traffic to. So once again, the control, the power, the revision, the versioning is all within the hands of the people who need to supply this information. So I really like that. Okay, before I move on to the next lab, which has a little bit more to it, any questions here? I'll go ahead and launch it and get it going while we're doing this.
You see the question here from Ryan, Carl.
Okay.
Ryan,
the browser blocked cross-domain cookies, which are required by this workshop. Which browser are you using, Ryan? I believe right now Chrome is supported and Safari is not, and I don't think IE is, but Firefox and Chrome should work. That might be interesting. Chrome and Edge. Yeah, Chrome should definitely work as well. Tell you what, I will follow up after with you on that to try to get to a resolution. Also, if you can, there is at the bottom of these screens, you see this KubeAcademy@vmware.com. If you send us an email there, I'll personally get it and I can help out. Yeah, sorry about that. Okay. Yes, and if you, for parts 1 and 2, AJ sent the links and the information, but if you do go to learning paths in Kubernetes and you scroll down to the Kubernetes core concepts one, you should see all the parts here. And we do have, I believe, maybe AJ can supply links. Some of these have been recorded and are up on YouTube, I believe, on the VMware Tanzu YouTube channel. And so we can have the recordings of the office hours in particular, if you'd like to watch those as well. I'm going to leave this lab up and open. So that way, if we have any questions that come in afterwards for this, we can keep going back to it. All right, let's get this lab going. I'll pause just another minute or so in case people are typing up questions. I know sometimes it can take a little while. And then I'll explain what we're going to cover here and the why. Okay, let me talk a little bit about why we called this resource organization and what we're going to talk about here. So, you know, when we are organizing all of our running apps within an organization, if you're not using Kubernetes, you tend to organize, you put things in environments, and then the servers that they're running on or the VMs that they're running on tend to group your applications together. In Kubernetes, we don't have that concept, right? The pods represent like a VM. The containers in the pod represent the installed applications on a VM. And then, but the pods can move from node to node. We don't control which, generally speaking, we don't control which node a pod runs on. So how can we group things together and perform isolation? And that's what we're going to talk about here, and hence why we called it resource organization, because how are we going to organize, and not just our pods, but also things like our services, our DNS scoping, our storage, and everything else. So it's not just running apps, it's the other stuff that goes along with them. All right, let's make sure we bootstrapped okay. Oh, that'll come back in a second. Yeah, it gets there. Yeah, and real quick, it's worth calling out. You might ask yourself, well, what was up with that crash loop, Ryan? You know, what's going on? Why is it doing that? And why are somebody's doing this? Remember, Kubernetes is eventually consistent, right? And it gets to that desired state. When I applied all of those YAML files in that script, everything just flew in, right? Normally, a lot of times we would do things where like, oh, let's start up the database, right? And we go over there and start up the database. Then we go check it. We make sure it's okay. And we don't start the web app that talks to the database until the database is up and running and safe, so we don't throw any errors. Well, in Kubernetes, we just throw all the YAML objects at it. And it's okay, because what's going to happen is the web server is going to start up, but it's going to either A, continually retry to connect, or B, crash because it's like, oh, hey, can't talk to the database, and it shuts down. But Kubernetes is going to continually restart it for us, right? It's going to keep trying. And so you're going to get a little bit of noise as that's happening, but eventually the system sort of simmers down and there's less change happening and it settles. And that's what we saw here, because we basically threw everything all at once. The web servers started up really quickly. Those images are smaller and their startup time is smaller. The database is a larger image, took time to pull from the registry. And also it takes a little bit longer to start up. So we had these databases going, or sorry, the web servers. And that's why we got into that sort of state. So as expected. Okay, cool. So let's, we're gonna talk about namespaces, right? So currently, if I run a kubectl command and say get pods, it's running it from whatever my current set namespace is, right? So if I look at my config and my context, right, I am currently using this namespace, labs W17 S65. And I can, we can see a bunch of namespaces in the cluster that are running because this is a shared lab environment we have out there. I see a bunch of other ones because probably some of you are following along. Now, I can't access all of those, but I can access some that are granted to me. I think mine was 65, if I recall from my context. And I have an environment variable set that's set in mine telling me it's a 65. So if we actually go and run that command again, and let's grep for the session namespace. All right, there's mine. Okay. And if we look at, oh, sorry. I want that one. Grep for the session namespace. I have that one, and I have an extra one. And what we did when we made the lab environment, we made just second namespace that you have privileges to, this one my namespace here. And so we're going to play around with both of these. So far, we've just putting everything in the labs into this default one. But now we're going to do a little different, right? So if we go and look at the pods in that other namespace, there are none, okay? If we look at the ones within the other namespace, right, there's the 3. So what we're going to do now is we're going to actually put ourselves and run things in each namespace and see how that affects things like DNS, IPs, and connectivity. Okay. So what we're going to do is in DNS, you have fully qualified DNS names, and then you have short names, right? So, right, it's the difference between talking to my database versus mydatabase.mydomain.com, right? And basically, namespacing follows the same pattern. If you are in the same namespace of other pods, those other pods that you're in the same namespace of, you can talk to both the pods and the services using their short name. If you're in a different namespace and you wanted to talk to a pod or a service in a different namespace, then you need it to be fully qualified. And we're going to test this right now, okay? So what we're going to do is we're going to run and we're going to launch a curl pod. So what we did here, this is shorthand. We basically launched a BusyBox with curl installed on it because it's not there by default. And what we're going to do, I am now running, right? If I go back over to here and say kubectl get pods, it's not there, but it's in that other namespace, right? or sorry, my apologies. I'm in the same namespace as the Go web app. Okay. So what we're going to do, we're going to curl Go web app. Okay. And we're going to try the fully qualified. Oh, I'm in the wrong one. Sorry. That makes more sense. Come on, return to me. Ah. There we go. Notice I got some HTML back, right? That short name worked. Well, you know what else is going to work? The long name should work as well. So let's replace it with the long name. Oops, a little bit too much on the copy pasta there. Should have resolved here. Oh, I need the session namespace. My apologies, folks. Okay. So I'll take that, and then we go back up here. We replace it. There we go, and that works too. Okay. Now, if I go and do the same thing, but launch it from a different namespace, right? So if I go back here and I exit out of this, and instead of here, right, I run it in I'm inside that curl pod. Okay. Notice it's that curl pod is not launched in this namespace, but it should be launched in the other one. Which is this one here. There it is. Okay, great. Now, if we go back and if I rerun Go Web App 8080, we will see it won't resolve. However, if I run it with the fully qualified, double dot, and 8080, then it should work. Web App Educates. This should be working. I'll look at it again. You need to supply that full namespace, and it works. Yes, thank you so much. I grabbed the wrong one. Knew something was wrong there. And so what's handy about this, you might say, okay, great, Ryan. And now I know this, like, what would I do differently? Well, what it means is when you're writing like your config file, right? So if I go back to the Go Web App, it had a configuration, JSON configuration file to it. And in there, the host name is just the short name. And I don't have to worry about actually putting in full names to things where you might have to in other environments. This is helpful because since they're in the same namespace, I can use this config. I can throw this whole stuff into any of the database and the Go Web App into any namespace, regardless of its name, and the connections will work without me having to hard code fully qualified things or make them configurable, etc. And that's sort of where one of the real wins come in on this. There's also wins in regards to firewall rules and a bunch of other stuff as well. All right, let me pause here and check the chat. Hello, folks. Yes, so this is open office hours so that folks can ask questions. And what I do to help stimulate some questions and to get some discussion going is for whatever part we're reviewing. In this case, we're reviewing part 3. I do the labs live, but I sort of just pick and choose some interesting things and add some extra example commentary about why we might do this. I mess some things up, as you see, and then we recover from them and see why they didn't work. And so that's the idea, that it can help spark some conversation and some questions, as opposed to just trying to openly make you sit here and just ask questions, or we have a bunch of slides. So hence the idea. If you have any particular examples you'd like me to try or questions that you're curious about, I can do them live here as we go through the stuff as well. Okay. So I already showed the context, the configuration view. So what we're going to do, we can also, let's see, I don't know if I want to do that. Let's go ahead and deploy to the other, actually, this is probably the more interesting part that I think we can go over. See how we can do it here. So in regards to interacting with pods and getting information from them, I want to talk about running remote commands in them. So if we go out of here, right, these are the pods running, and I can use some of the other stuff. So let's say that I'm trying to debug a pod that's running in a particular namespace. I'm trying to see where to put things, and I'm wondering why, is that pod actually there accepting traffic and working independent of the inbound traffic through Ingress, cross namespaces, etc. Now, I was able to run that curl pod and do it that way. Another way to do this is to actually port forward that to my client. Okay, so kubectl has a port forward command. Okay, and what it is, it allows us to bring attached to one of the ports on the running pod and then direct that to my local machine. So imagine you're on your laptop, you're outside the data center, and then you're going to open up a port. kubectl will open up a port on your local machine, local host, that if you send traffic to there, it's as if you were inside the cluster and sending traffic directly to that pod. Okay. So as you can see, let's go ahead and do this. Whoops, sorry. So kubectl port forward, and let's do one of the Go web apps. Let's do this top one, the RM one, right? And do 8080 to 8080, I think. Okay. Now it's actively going here, right? And so if I curl localhost 8080, I get the website back, right? These are two terminal sessions essentially inside the same area. If I stop this and then, we don't get anything. So this is another way if you want to bypass, right, all of the inbound ingress and everything else and saying, let me make sure that an individual pod is actually functioning correctly, the application in it, then you get that benefit. I will check, we see what's up with that email address. It should be working, but you know how things happen. Okay. Let me pause for any questions on the port forwarding before I go to one other thing I want to do. Okay. Okay. I want to talk about this thing in regards to networking and in regards to organization of stuff. I want to talk about these endpoints. They're not talked about a whole lot. What it is that endpoints is basically an array of the pods that are going to receive traffic from that service. So 130.25 and 204.88 are going to be the IP addresses of the two web server pods. Okay. And then what address port on those to talk to. And so you can actually look at you can also get the individual endpoints. Okay. They're modeled as different objects in Kubernetes. And when I describe, it's actually going and fetching the endpoint associated with that. When I describe the service, it's fetching actually extra objects. Just like when I do, and I describe a pod, the events at the end, right? Those are that's a different resource, a different object, but the describe command went around and found the connected or associated objects and then put them in the same spot for me. And so what we have here, give ourselves some more room to just do that. And we see endpoints for the MySQL and endpoints for the Go Web App. And so if I were to take down a service, right, it should go away from this list as well. So this is like a resolved list. So let's go and see. We can play around and see and say, hey, you know, what if we make one of these web servers no longer work? Can we do that? Can we break something, right? So let's go ahead and let's go into one of these Go Web App pods, see if we can. Let's go into the RM one again. So I'm inside there. Okay. Let's see if I'm able to break it. So there's the Go Web App binary and there's static content, right? Well, I wonder if I can delete that. Ah, no, I can't. Yeah, I protected myself. What I was going to try to do was go in and actually mess with the file system of the Go Web App and actually manipulate it so that it would be throwing 404s, which then would have failed the service request, which would then take that pod out of service, and hence our endpoint list would be adjusted. I forgot that the initial versions of this course, we were using a privileged containers, right? But what we did to go in line with security best practices, we actually enhanced the Docker containers that are running within the Go Web App pods to be non-root or not privileged containers. If we go and look at the Docker file that we used for this, we specifically set the user to be a non-root user by default. If in Docker, if you don't specify that, it goes as user 0, I believe, and does as root. And so basically by doing that, it's a security best practice so that like if somebody were, if there was some remote code execution or something like that that would have been run on this, you might be able to get in and see some stuff, but you wouldn't be able to make changes. So it's an extra layer, and that's why I couldn't go in and do that. But we would see those endpoints change, and it's another debugging thing is to say, hey, I'm hitting the Ingress endpoint and I'm getting like errors, right? Nothing is handling my request. And you can come and look at the endpoint list and say, well, are there any backing it or not, right? So if I were to actually, we can simulate it, right? So if I kubectl describe service go web app. Okay, and I kubectl get ingress. There should be an ingress in here. Right, so here's for this lab, here's my running URL. There's the app, right? And so then if I go, and it should work from here too. I think we got wget installed here. No, curl. No, we don't have either of them. I don't think. Oh, there it is. Yeah. Okay. Curl installed, not wget. All right. So what we can do is I can take the Go web app deployment. Let's change that replicas to 2 from 2 to 0. Our pods are shutting down. If I get the endpoints, notice Go web app has none. If I refresh this page, well, we got some caching going on. Oops. Shut that one. No healthy upstream. Yeah, let's not rely on the browser, right? And notice what we got is the Ingress controller sent us a 503 service unavailable, meaning, hey, I got your request. Hey, I know what I'm supposed to do with it, but I have no backends to send the request to. So I'm going to give you the 503, the service unavailable. Like I say, I think there's some caching going on here on this side of it. So I apologize. Oh, that was from the other lab. There we go. That's what I wanted to see. And the same thing here, but it actually resulted in the 503. So that's a little bit about the endpoints. We didn't go a whole lot on it, but it's another thing I like to share when and go over when I'm doing this live in front of folks or people asking me questions. So with that, that's sort of the end of the prepared stuff I was going to go through while people put questions in. So I'll stop here and sort of hang back for chit chat and see if any other questions have come in the chat about what I went over or any of the content or topics covered in part 3.
Thanks, Ryan. As we wait for questions to come in or any comments to come in, we did include both YouTube videos for part 1 and part 2 of our previous office hours from the last few months in the chat. I'll surface them again near the end of this as well, so people have them all in one place. And then although we don't have the landing page created just yet, we do have part 4 taking place in August. So we will be sharing out that link post-event as well.
Yeah, and it will show up here. If you click the resources in KubeAcademy, under the webinars. Once it's available, it will show up here as well. So it should. Yeah, there's a lot there, but hopefully it all made sense. And debugging and trying to break something or try to do some of the stuff I did on your own is some of the best way to learn this stuff. Give it a test, figure out why, etc.
We did get a question come in here from VJ. I think it looks like, can you please talk about sidecar containers and potential use cases?
Sure. I'm going to help with that. Oops.
Thank you for the question, by the way.
Yeah, thanks, VJ. I'm gonna go to in lesson 2 here in this video. I'll just do this for ease. Let's go to this slide and I'll just sort of talk live about it. So one of the way I like to think about sidecar containers is to talk about the relationship of pods to VMs. Okay. So basically a pod is like a VM. And the containers that run inside the pod are like the installed applications on a VM. So imagine in this scenario that this word, I think I have it there, right? Yeah, here we go. Imagine here that the word, VM and is synonymous to pod. And so I basically booted up a VM, Windows or Ubuntu, and then I installed a web server on it. And then I installed a second application that synced data from Git periodically or kept it in sync, and the web server pointed to that same space on the VM. It's the same concept, okay? And so a lot of times people would ask me, like, Ryan, like, hey, when should I have like one pod with a bunch of containers in it, or when should I have a bunch of pods with only one container in it? And basically my answer most of the time is like, well, what would you do with your VMs? Would you put the database and the web server on the same VM? Typically, the answer is no, you would not. And so those would be two separate pods, one container each. What if but other scenarios, you might actually do that, right? And so it's really, it depends scenario, but the core architecture, decision and design, et cetera, goes back to that right there. So, to your question about the benefits and the use cases, if you can think of throughout your career, or maybe the projects you're on now, scenarios where you've had a VM that's been running more than one thing on it, that's a good example of where you'd have sidecar containers. Another example, sometimes I've run some applications in the past in my career where instead of terminating SSL at a higher layer, at the load balancer layer, and then having unencrypted traffic from the load balancer to the actual individual web servers, instead we had, to keep things extremely secure, we kept the SSL through the upper level load balancer all the way into the individual VMs supporting that. And so on those VMs, we had the actual application, which was a Java REST application, but it only exposed port 8080 on localhost. Then we ran another process on the same VM, which was HA proxy, that basically did the SSL termination on the actual individual VM and then sent traffic after it decrypted it over localhost to the Java app running there. And in that scenario, HA proxy was a sidecar application on the VM. If I were to duplicate that kind of configuration in Kubernetes, I would have a pod where I'd have two containers, the Java application and the HA proxy running, sending and talking over local host. And the Java app would never be, you'd never be able to talk to it other than on over local host within the pod and through the sidecar container. So hopefully that helps give you both visual here, the why, how you can relate it to architectures you've done in the past, and then also in general, so another use case example. Cool, great. Another question from Jose. Besides survivability of services across pods, are there any security reasons to separate apps across nodes and pods? Or is that what namespaces are used for? Okay, so apps across nodes, pods represent the running instances of an app, right? So if I have the same Java app or the same web server and I'm running 5, 10 copies of it, those pods all represent instances of the same app. And so if I run them across, you don't really run them across, separate. I can run across separate nodes. The namespaces is really to say a grouping. So I think I have a slide on this too somewhere, and I'll go but pull it up in parallel while I talk. Namespaces do a few things for us. One, they provide that DNS scoping. Two, there's some implicit networking policies that apply. So a lot of times when you get your namespace granted to your team that's deploying an app, there will be basically a firewall rule in the Kubernetes, a network policy, as it's called, that will say, hey, the stuff running in that namespace, so the pods running in that namespace, they can't receive any traffic from anywhere in the cluster other than pods running in the same namespace. Namespace is agnostic. It has nothing to do with nodes within a cluster. So it doesn't matter whether the pods for that namespace are on 1 node, 2 nodes, 5 nodes, different nodes, doesn't matter. It is a logical construct, not a physical construct. Okay. And so the other big thing from a security perspective that the namespaces help with, and I get to this in a second, is permissions. So typically, the permissions for allowing granting access to people for things tend to go, yes, here we go. Let me pause it where I'm not looking as terrible. The other thing is I grant people access to other namespaces as an administrator in a cluster, right? So you can just say, hey, a person in this group or this particular user account, they can read and write pods and make changes within a namespace, but they can't touch other namespaces. Here's a good example. If we go back to, I'll restart one of these labs. Sorry, I thought I had it still running. No, I do have it running. Okay, cool. Little garbity gook there. All right. So let me just go terminal heavy here. There we go. Whoa. There we go. kubectl get namespaces, right? I can see these. And when I get pods, I'm getting the pods out of the namespace that I'm in right now. And remember, I was able to get pods right? And then I was able to look at the my namespace, right? Now watch what happens if I try one of these other ones. If it fails, I get a problem. If it succeeds, I have a problem, right? Permission denied. So basically, from a security perspective, we typically, it's very easy in Kubernetes, we give read, write, and those kind of permissions at the namespace level as well, both to users and to applications too, and service accounts. So I know it was a little bit long-winded, but hopefully it gave you a rough idea of how the namespaces can help with security outside of just organizing things. Cool. All right. Well, I think we're almost at top of the hour, and I appreciate the questions and the patience for those to type them in and bear with me while I explain them and answer them. And if there's any more that come in, I'll answer them. But otherwise, I'll turn it over to AJ, and I'll thank you all for being here today and for hopefully leveraging the content that we have out there and that we continue to add.
Thank you, Ryan, for today's presentation. Thanks to all of you guys for joining us. Like we mentioned, we'll stay on just a little longer to see if there are any other questions that come in, but do some of the comments come in. Thank you, Jose. Thank you, VJ. Thank you, Ken. Thank you, Enrique. Thank you, Ryan. Thank you, everyone, for joining us. Thank you for all the great comments. Like we mentioned before, this will go up on YouTube shortly, so you'll be able to view not only sessions part one and part two, you'll be able to view this again or share this with any of your colleagues. We also will be coming back with part 4, I believe on August 11th. So we'll be sharing the link to the registration page in our post-event email. So thank you guys again. Ryan, it's been a pleasure, always a pleasure. Looking forward to doing part 4 with you as well. And if I don't see any other comments or questions coming in, so we can give folks some time back. So everyone have a great rest of your Thursday. It's almost Friday. Have a great weekend. We'll see you guys soon.
Thank you all. Take care.
Bye all.